We're here at Lowe's today to discuss some fertilizers and their effect on the Barnegat Bay. Three chemicals present in fertilizers are nitrogen, phosphorus, and potassium. Chemicals found in fertilizers that are detrimental to local waterways include nitrogen, phosphorus, and potassium. Nitrogen is a limiting factor in the growth of bacteria and a chemical that fuels plant growth. Phosphorus is an inorganic chemical that is a fuel to algae growth. Potassium enhances the germination and emergences of algae. Algae is the main food source for developing sea nettles. Now we're going to take a closer look at a bag of fertilizer. The 18 represents nitrogen. This 18 means 18% by weight. The 24 is the phosphorus, 24% by weight. And the 6 is the potassium, 6% by weight.
Hi, we're here at Caddis Island today to talk about the life cycle of the sea nettle. There are 5 stages in the sea nettle's life cycle. There are the planula larva, the polyp, the budding polyp, the ephyra, and the medusa stage. The first stage of the sea nettle's life cycle is the planula larva. The planula larva hatches from an egg and floats around the water column until it settles to the bottom and attaches itself to a hard surface. Next, the planula larva turns into a polyp. The polyp then turns into a budding polyp, where it produces up to 50 ephyra. Budding is reproducing by making copies. The ephyra stage is also known as the juvenile jellyfish stage. These young jellies are controlled by the currents and are the stage in the sea nettle's life cycle that is most affected by fertilizers. Fertilizers dramatically increase the growth rate of algae. Algae is the main food for the ephyra, and an overabundance allows the ephyra to develop quickly. Once the ephyra have fully developed tentacles, they become the medusa stage. These fully developed jellyfish have some control over their movement in the water column. The sea nettle can grow to be 10 inches in diameter and have up to 25 stinging tentacles. They live in water temperatures ranging from 18 to 30 degrees Celsius, with a salinity ranging from 10 to 20 parts per thousand. A fully developed female sea nettle can produce up to 40,000 eggs.
Hi, we're here at Caddis Island County Park doing an interview with John.
Hi, my name is John. I work at Caddis Island County Park. I'm the head animal curator. I've been here 5 years. And you guys wanted to know about jellyfish?
Yes.
So I have here for you guys a model creasel plankton tank. This is basically a very simple and homemade version of a jellyfish tank that you guys could find, say, at a large aquarium, Baltimore National Aquarium, something like that. And the way that this works is the water comes up through this side here and flows over this little dam and then circulates inside the tank so that the jellyfish don't get sucked up into the filter. That's why we have a fine mesh here. This way the jellyfish, which need to be constantly suspended because of their high use of oxygen, they can stay constantly suspended in the tank and circulate the tank while the water gets filtered, sucked out through here, through the filter, and then pumped back in, so they're in constant rotation. This, like I said, this is an easy, simple one.
Have you seen any increase in sea nettle populations since you started?
Personally, yes. There's a couple different reasons why they think that it's been increasing. Some of it, the theory that I favor a little bit more, is because of nutrition runoff and that kind of thing into the bay that jump starts the plankton, which the comb jellies, the ctenophores, eat, which the sea nettles eat the ctenophores. So you have a big, vicious cycle going on with that.
Is there anything that the average person can do to limit their impact on coastal estuaries and sea nettle populations?
Yeah, watch your runoff, especially like that ChemLawn stuff and fertilizers that you add to your lawn, because plankton is a plant. So if the more runoff that we have, the faster it'll increase like that. And like I said, it's one theory. I don't want to try to preach one thing to you, because there's a couple different ones.
How has the increase of sea nettle populations affected the overall health of the Barnegat Bay ecosystem?
Well, it can kind of jumpstart a eutrophication process. I mean, if it's extended, you guys could study the effects of sea nettles in the Delaware River too, because the sea nettle population has gotten so bad that supposedly it's pushing out native fish and hindering the normal food web, because the sea nettles are stinging larger fish, and of course nobody wants to get stung. You know, if you guys have gone swimming in the Barnegat Bay lately, you know, it's not fun when you brush up against a sea nettle.